Hello children, welcome back to your 7th standard mathematics class. Today we begin lesson number 9, direct proportion and inverse proportion. First let us see what is meant by proportion. Proportion is a concept in mathematics which gives the relation between any two mathematical quantities. Two quantities are said to be proportional if they are multiplicatively connected by a constant. The proportional relationship between any two quantities can also be defined as the quantities whose product or ratio is constant. This means that two quantities are proportional if they are connected each other. And in a proportion, the two quantities are related in such a way that either their ratio is a constant or their product is a constant. Now let's see what is meant by direct proportion. Two measurable quantities are said to be directly proportional if the increase in one quantity results in the increase of the other quantity and vice versa. That means, in a direct proportion, the two related quantities will change in such a way that the increase in one quantity will result in the increase of the other quantity, or if one quantity decreases, the other quantity will also decrease. Now in direct variation, the ratio of the two quantities is a constant. Also, direct proportion is a relation between two measurable quantities where the ratio of the two is equal to a constant value. Now let us understand this using some examples. Look at these pictures. We see divisions of a circle made by the diameters. Now, do you see a relationship between the number of diameters and the number of divisions they give rise to? Yes. In figure A, there is one diameter. And how many parts are there? There are two parts of the circle. In figure B, there are two diameters and the number of parts have increased. In figure C, there are three diameters and the number of parts have increased to 6. In figure D, the 4 diameters makes 8 parts of the circle. So if you take the ratio of number of diameters to number of divisions, in the first case, the ratio is 1 upon 2. In figure B, it is 2 upon 4, which can be reduced to 1 upon 2. In figure D, it will be 4 upon 8, which again can be reduced to 1 upon 2. So we see that the ratio of number of diameters to the number of division remains a constant 1 upon 2. Let's see another example. The number of notebooks that students of a government school received is shown in the table below. So, if there are 15 children, you require 90 notebooks. 12 children, you require 72 notebooks. 10 children, 60 notebooks, and 5 children, 30 notebooks. So in this case, we see that when the number of children are reducing, the number of books also have reduced. That means this is a direct variation. So, since it's a direct variation, the ratio of the number of children to number of notebooks has to be a constant. Let's check. In the first case, it is 15 upon 90, which when reduced will give you 1 upon 6. Similarly, each of these ratios can be reduced to a constant 1 by 6. So from the above two examples, we see that when the number of diameters increases, the number of division also increases. In the second case, as the number of children decreases, the number of notebooks also falls. So here both these cases are examples of direct proportion. Let's take another example. The amount of petrol filled in a motorcycle and the distance traveled by it. Is it in direct proportion? Yes. If you have more petrol, you can travel more distance. If you have less petrol, you can travel only a small distance. So it is an example of direct proportion. Let's see another example. If 10 pence cost 60 rupees, what is the cost of 13 such pence? So let's suppose that the cost of 13 pence is x rupees. Now here the number of pence and their cost vary in direct proportion, because as the number of pence increases, the cost also increases. Since it's a direct proportion, the ratio of quantity to cost will be a constant. So we can write 10 upon 60, that is 10 pence, and the cost is 60 rupees. So we can write 10 upon 60 is equal to 13 upon x. From this we can find the value of x, which is the cost of 13 pence. So you will get the answer as the cost of 13 pence is rupees 78. Now let's solve practice set number 37.
The first question, if 7 kg onions cost 140 rupees, how much must we pay for 12 kg onions? So here if you see, the weight of onions have increased from 7 kilos to 12 kilos. So when the weight has increased, the cost also will increase. So this is an example of direct proportion. Now we have to find the cost of 12 kg onions. Let us consider that the cost of 12 kg onions is x rupees. So let's write that first. Let the cost of 12 kg onion be x rupees. The weight of onion and its cost are in direct proportion. As this is an example of direct proportion, we know that the ratio of weight of onions to the cost of onions will be a constant. Therefore, we can write 7 upon 140 is equal to 12 upon x. Now let's cross multiply. So we get 7x is equal to 140 multiplied by 12. Therefore, x is equal to 140 multiplied by 12 divided by 7. We can cancel 7 and 140. So we get here 20. Therefore, we get the value of x as 240. That is, the cost of 12 kg onion is 240 rupees. So your answer is, we must pay rupees 240 for 12 kg onions.
We will solve the remaining questions in the next video. Please practice the sums solved in this video. Thank you and have a nice day.